Welcome to the Deep Dive. We're here to unpack those pivotal moments in tech history, the ones that made you think you know, but have secrets hidden inside.
Exactly. And today, we're going somewhere pretty spectacular.
Yeah, let's picture this. New York City, 1898. You're inside the brand new Madison Square Garden. It's the electrical exhibition.
Right. Think Gilded Age glamour, the air just buzzing, literally, with the new inventions. Incandescent bulbs everywhere, giant dynamos humming away. Electricity is still, well, it's basically magic to most people.
Pure spectacle. And that feeling, that sense of wonder, is kind of crucial for what happens next, isn't it?
Oh, absolutely, because into this scene walks Nikola Tesla. He goes up to this specially built indoor pond.
Like a big tank.
Yeah, big tank. And he reveals the small iron boat, sleek-looking thing.
Maybe 4 feet long. I picture it with like little antennas sticking up.
That's the one, and then it starts moving all by itself, stopping, turning, doing these complex patterns. It just moves with this weirdly lifelike intention.
And Tesla, he's just standing there.
Yeah, just standing there holding a small wooden box, no wires, nothing visibly connecting him to the boat. Total mystery.
Okay, so the crowd must have been absolutely floored. What were they thinking?
Well, they had no frame of reference, right? Radio control wasn't a thing anyone had conceived of. So theories were flying, magic, maybe telepathy. But the favorite, the one that really caught on, was that he'd somehow trained a monkey and, hidden it inside the boat.
A monkey? Seriously, that was the leading theory.
That was a popular one, yeah. And Tesla, always the showman, he kind of leaned into the whole mystery of it.
Yeah,
He would get the boat's little lights to blink in response to questions from the audience. Someone shouts out, "What's the cube root of 64?" And the boat's lights flash 4 times.
Pure theater. Brilliant.
But
But distracting, maybe.
totally distracting from the real revolution happening right there. What people were actually seeing, hidden behind the magic, was the birth of remote control. Robotics, really. Tesla called it a teleautoton.
Teleautomaton. And he saw it as more than just a boat, didn't he?
Much more. He actually called it the first of a race of robots. A prophecy.
Okay, but here's the part that just blows my mind, the bit we really need to dig into today. That patent he filed for the boat, U.S. patent number 613,809.
Right.
Hidden inside the technical description, almost as a side note for security, was the world's first electronic logical A&D gate.
That's it. That's the core of our deep dive today. We're going to show you how this little boat wasn't just the ancestor of, your RC car or a military drone. It was actually laying down a fundamental piece of the foundation for all modern digital computers. It connects Niagara Falls to the AI in your pocket. It's an incredible through line.
Wow. Okay, so before the boat, before the A&D gate, we need to understand the man. Where did this kind of thinking even come from? How did he get from lighting up cities to controlling machines with invisible waves?
Well, you have to go back to his roots. Born 1856, Smiljan in what's now Croatia. And his mother, Jagoka, seems to have been really key.
He was an inventor too, right?
Yeah.
But more homespun stuff.
Exactly. No formal schooling, but constantly inventing household gadgets. Things like specialized egg beaters, tools for weaving. Tesla himself said his inventive streak came directly from her, from that influence. Plus, he had this insane memory.
And the technical spark, the big AC idea, that came later at university.
Yeah, at the Polytechnic in Graz, there was this professor demonstrating a DC motor, a Graham dynamo, and it had these commutators, these brushes.
You things that spark like crazy.
Right, constantly sparking, super inefficient, needed to keep the current flowing one way. And Tesla, as a student, apparently just blurts out, why not get rid of them altogether?
And the professor.
Laughed him off, said it was like suggesting perpetual motion. Impossible. Foolish.
But that dismissal lit a fire under him, which leads to that famous story. 1882, Budapest.
That's the one. He's walking through a park with a friend, reciting poetry Goethe's Faust, the story goes, and suddenly it hits him. The solution.
Just like that.
Just like that. The principle of the rotating magnetic field. Use multiple AC currents, slightly out of sync, and you create rotation without needing those sparking brushes. Smooth, efficient.
And that insight basically kicks off the whole war of the currents. Edison digging in his heels with DC.
Which was clunky, mathematically messy for transmission.
While Tesla's AC, backed by George Westinghouse, could be sent efficiently over huge distances. That was the key advantage, right?
Absolutely. Step up the voltage, send it miles with minimal loss, step it back down. That's why AC won.
We saw that win spectacularly at the 1893 Chicago World's Fair, the City of Light, all Tesla's AC.
a massive demonstration. And then 2 years later, 1895, harnessing Niagara Falls. That really cemented AC and Tesla's reputation as, well, a wizard of electricity.
Okay, so he's mastered power delivery, but the boat in Madison Square Garden, that required mastering something else entirely. Sending control signals wirelessly. What were the steps leading up to that? How did he get into radio?
Well, the engine for that was the Tesla coil, which he developed around 1891.
The thing everyone knows from science fairs. Big sparks, lightning bolts.
Yeah, it looks spectacular, but its real purpose was scientific. It's a resonant transformer circuit. Its job was to create extremely high voltage, high frequency alternating currents.
And you need that kind of power. Why?
To generate strong, coherent radio waves that can actually travel a meaningful distance and carry information reliably.
Okay, so the coil gives him the power source for radio. But radio itself,
Yeah,
that's where things get a bit contentious historically with Marconi.
it really does. Look, Marconi gets a lot of the popular credit, but the patents tell a story. Tesla filed his fundamental radio patents. We're talking U.S. patent numbers 645,576 and 649,621 back in September 1897.
Months before the boat demonstration.
Right. And these patents laid out the core ideas, using 4 tuned circuits, sender and receiver matched, and what he called selective tuning, or the art of individualization, making sure only the intended receiver picks up the signal.
And wasn't there a Supreme Court case about this later?
There was. In 1943, the U.S. Supreme Court actually upheld Tesla's radio patent priority over Marconi's. So legally, Tesla got there first with the core concepts.
So he's got the coil for power, the patents for the radio system. Why pour all that into what looks like, frankly, a toy boat? Seems like an odd application.
It seems odd out of context, but it was incredibly strategic. Tesla had this massive, almost unbelievable vision, the World Wireless System.
Wardenclyffe Tower, global power and information, free for everyone.
That was the dream, broadcasting energy and communications across the planet without wires. But that needed huge investment. He needed to convince serious money people, guys like J.P. Morgan.
So the teleautomoton boat wasn't the end goal. It was a sales pitch.
Exactly. A brilliant, tangible proof of concept. It showed these skeptical financiers, look, I can send complex, precise commands wirelessly over a distance and make something happen. It made the giant leap to global wireless seem, well, slightly less insane.
Made the abstract concrete. Okay, that makes perfect sense. Now let's get into the nuts and bolts of that boat, the pattern details. How did it work?
Okay, so the boat itself was self-contained. Batteries on board for power, motors for the propeller and the rudder. And the absolute key radio component was something called a coherer.
Coherer. Sounds descriptive. What was it?
Basically a small glass tube filled with tiny metal filings, like metal oxide powder. Normally this powder is loose, doesn't conduct electricity well, it's an insulator.
Okay, so the radio wave comes from Tesla's box, hits the boat's antenna. Then what?
That electromagnetic energy from the wave hits the powder and causes the little metal grains to suddenly cling together, to cohere, just for an instant.
And when they stick together?
They become conductive. The powder bridge suddenly allows current to flow. It completes a circuit, so the coherer acts like a switch that's flipped on by a radio wave.
A radio-activated switch. But wait, if it just turns the circuit on, how did he get the boat to do different things, like go forward, then turn right, then stop? It wasn't just one command.
Right, that's the next layer of genius. The current from the coherer didn't directly power the propeller or rudder. Instead, it energized a little electromagnet.
Okay.
And that electromagnet's job was to advance a rotating disc, like a little steampunk mechanism, one click forward. Think of a rotary switch or a dial.
So each radio pulse clicked the disc to the next position.
Yeah, exactly. And this disc had electrical contacts arranged on it. It was basically a mechanical state machine programmed physically.
A state machine.
Right.
I mean, like, position 1 on the disc connects the battery to the propeller forward motor.
Precisely. Then the next radio pulse comes, click, the disc moves to position 2. Maybe that position connects the rudder right motor. Pulse, click, position 3, connects propeller stop. It's stepped through a preset sequence of actions.
Wow. That's incredibly intricate for the 1890s.
Yeah.
One more thing, though. If the radio wave makes the powder stick together, how does it get unstuck to receive the next pulse? Does it just stay conductive?
Good question. No, it had to reset. After the electromagnet clicked the disc forward, another little mechanism, basically a tiny tapper or vibrator connected to the system.
A shaker.
Sort of, yeah. It would give the coherer to a little jolt, physically breaking the connection between the powder runes, making them non-conductive again. Ready for the next radio command.
So receive pulse, cohere, complete circuit, advanced disc, Execute action, tap, reset, all in an instant.
That's the sequence. An amazing piece of electromechanical design.
Truly astonishing.
Okay.
Okay, now for the hidden gem. The part that connects this Victorian-era robot boat to modern computing.
Yeah.
The logical A&D gate. Where does that fit in?
It came from Tesla's obsession with security and control. He immediately saw the problem. If anyone could just blast the right frequency, they could hijack his device or jam it, especially if it was, say, a torpedo.
He needed a way to make sure the command was authentic, only from his transmitter, like a password almost.
Exactly like a password, but using radio frequencies. His solution, described in the patent, was ingenious. He designed the receiver system so that it would only execute a command, only advance that disk, if it received signals on multiple, specific, different frequencies simultaneously.
Whoa, wait, not just one frequency, but several, all at the exact same time?
That's the key. Let's say it needed frequency A, frequency B, and frequency C. If only A and B arrived, nothing happened. If only C arrived, nothing. The mechanism wouldn't trigger.
It had to hear the whole chord, not just one note.
Perfect analogy. The output advancing the disk would only be true if and only if input A was true, and input B was true, and input C was true, all at the same moment.
Output is true only if all inputs are true. That is the definition of a logical A&D gate.
Precisely. The very first electronic implementation of a fundamental logic function, the bedrock of all digital circuits, hidden inside a remote control boat patent in 1898.
Honestly, that reframes everything. It's not just remote control, it's the dawn of digital logic, too. He basically invented multi-factor authentication for his boat.
You could absolutely see it that way. And this incredible leap immediately highlighted that classic tech dilemma, creation versus destruction.
Right, because the obvious first thought for anyone seeing this, especially back then, must have been weapons.
Absolutely. Teleautomatic torpedoes, he called them. The world's first drone strike capability, essentially. And the sources even say Mark Twain. Yes, that Mark Twain.
Yeah, author.
The author. He was apparently so blown away by a demonstration that he offered to act as Tesla's agent to sell this destructive terror, as he put it, to governments around the world.
Mark Twain, international arms dealer. You can't make this stuff up.
It's pure Gilded Age ambition and weirdness. But Tesla himself had a more complex, almost paradoxical view of the weapon potential.
How so? He wasn't just about building better weapons.
No, he argued the opposite in a way. He believed that by making weapons so powerful, so automated and destructive, the cost of war would become unthinkably high.
So destructive it would force peace.
Exactly. He thought it would lead to a permanent peace among nations. It's basically the core idea of nuclear deterrence, but decades before the atomic age.
Yeah.
Eerily prescient.
Decades ahead. But even beyond the weapon idea, his real vision for the teleautoton was broader, wasn't it?
Much broader. He famously corrected a reporter who called the boat a wireless torpedo. Tesla said, and this is a direct quote, "You do not see there a wireless torpedo. You see there the first of a race of robots, mechanical men which will do the laborious work of the human race."
Wow. Not weapons, but workers.
Yeah.
Automated servants.
That was the ultimate goal. And he made a crucial distinction later on. He said his current automatons, like the boat, had borrowed minds. They needed him, the operator.
They were remote controlled.
Right. But he predicted future machines that would have their own mind. Machines that could react to their environment, make decisions, perform complex tasks without an operator.
That sounds like AI. Autonomous agents. He was describing that in the early 1900s.
Astonishingly, yes. An incredibly early, clear description of autonomy.
Okay, so let's follow that thread. From his boat, his borrowed mind machine with its electromechanical logic, to the devices we have everywhere today. How did we get here? The principle stayed, but the tech changed radically.
Radically. The delicate coherer and those clicking mechanical relays, they were ingenious but fragile and limited. The next big step involved vacuum tubes starting around the 1930s.
Bulky, hot, power-hungry.
Yep, but they allowed for amplification and more complex electronic circuits than relays. Then, the real revolution. The transistor, 1950s, 60s.
Miniaturization. Everything gets smaller, faster, cheaper, more reliable.
That's the game changer. Transistors paved the way for the complex multi-channel radio control systems we started seeing in hobbyists and industry. And then, integrated circuits in the 70s just put it all on hyperdrive. Suddenly, complex control systems could be mass-produced on tiny chips.
But even with transistors and ICs, you still had Tesla's original problem. Interference. Lots of people using radios, signals crossing. How did we solve his art of individualization challenge in the modern era.
The elegant modern solution, especially for things like Wi-Fi, Bluetooth, and modern RC systems, is spread spectrum technology, often in the 2.4 gigahertz band.
Spread spectrum, what's that involve?
Instead of sticking to one single frequency that could get jammed or crowded,
Right.
the transmitter and receiver agree on a secret pattern to rapidly hop between many different frequencies, dozens or even hundreds of times per second.
Frequency hopping. So if one frequency is noisy or busy, they're only on it for a tiny fraction of a second before jumping somewhere else.
Right, exactly. It makes the connection incredibly robust against interference. It's the ultimate digital answer to Tesla's original analog need for secure, individualized control.
A direct line from his multi-frequency A&D gate concept to modern secure communications.
Amazing. Which loops us right back to the legacy. Every drone flying overhead, every RC car zipping around, the robots on assembly lines, even your smart thermostat talking to your phone.
The Internet of Things.
All of it. They are all descendants of that little boat bobbing in a tank in Madison Square Garden in 1898. Tesla's teleautomoton wasn't just the first drone. You could argue it was the first real smart device.
So the debt we owe Tesla is huge, and maybe twofold. He's clearly the father of remote control. No argument there. But he's also this forgotten pioneer of digital logic, slipping the first A&D gate into the world almost unnoticed.
Absolutely. And that brings us to the final thought, the provocative question, maybe. Tesla saw the path clearly, from the borrowed mind of remote control to the own mind of true autonomy.
Right.
So, as we build ever more sophisticated autonomous systems today, self-driving cars, AI that can learn and adapt, we have to ask you, the listener, are we finally realizing Tesla's dream of creating tireless robot helpers to free us all from drudgery?
Or are we just perfecting that teleautomatic torpedo he showed the world over 120 years ago, maybe without fully considering the implications?
That's the question his legacy leaves us with. Something to think about.